When we're working with algebra, we can run into situations where fractions are mixed with other fractions or divided by other fractions or inside of other fractions. This is known as complex fractions, and how we treat it is basically if we have a fraction bar between two sets of fractions, we're basically dividing this set of fractions by this set of fractions. So what we do is we just simplify each part of the fraction bar as much as possible, and then we divide the bottom from the top. So let's go ahead and try that for this specific example. What do we need to do for the top? Well, the best thing we can probably do is multiply this over here by the common denominator and combine it into one fraction. So let's go ahead and do that. So we have 1 over 1 here times x over x, right, to get a least common denominator, minus 1 over x. So we have x minus 1 over our common denominator of x. So now we have the bottom. Our bottom portion of this example is x minus 1 over x squared. So what we need to do is just find the common denominator for these and combine them into one fraction. Let me bring it up here. So we have our top, x minus 1 over x over our bottom. So what's our common denominator here? The least common multiple, least common denominator, the highest exponent of each unique factor. So we have 1 and we have x squared. So our least common denominator is going to be x squared. So in order to get this into our least common denominator, we need to multiply it by x squared over x squared. And then our 1 over x squared already has the least common denominator, so we don't need to multiply it by anything. But now we can combine this into one fraction. So we have our top, x minus 1 over x over x cubed, right? Minus 1 over x squared. So we have simplified the top and the bottom of the fraction bar as much as possible. Now we can write it as this. So it's our top divided by our bottom. That's what the fraction bar means. So I'll write it right here just so you can visualize it better. You don't always have to do this step, but that's just to show you that the fraction bar is the same as the division symbol. So now what we do when we divide this, we just flip the second thing. We flip the thing after the division sign, so we can write this as x minus 1 over x times x squared over x to the power of 3 minus 1. So we could just go ahead and multiply this, and that gives us x squared times x minus 1 all over x cubed minus 1. And you can multiply this out all the way, but for this example, we'll just go ahead and leave it, so that will give us our solution for this example. So here is another example of a complex fraction that we can simplify just by factoring the top and the bottom part of the big fraction separately and simplifying, and then towards the end we'll just treat this big fraction bar as a division sign, flip the bottom one, and multiply them. But first, let's factor this top portion here, because maybe we can cancel something first. But let's just bring it down. So what do we have here we have a, looks like a perfect square. So how do we factor a perfect square? Well, we have the square root of the first term and the square root of the third term and the sine of the second term, all that squared. And then over a minus b. Well, look at that, we can cancel. So all that over our denominator here, a cubed plus b cubed over a squared minus b squared, which is a perfect square also, so we'll end up factoring that. But this cancels, right? Whoa. Excuse my chalk. So let's bring this up here. So we're left with just a minus b on top, all over our a cubed plus b cubed. And if we factor this as a perfect square, or a difference of squares, excuse me, how do we do difference of squares? We have square root of the first term plus square root of the second term, and then the square times the square root of the first term minus the square root of the second term. Now, it doesn't look like we can simplify any further, so we'll treat this as a division sign and multiply them both by flipping the bottom one. So we have here, this is a over b, or a minus b over 1. So a minus b over 1 times this flipped, right? Do you see why we did that? So I just skipped the step where I write it as a division problem because you know what the fraction bar does. So we'll flip this. We have a plus b, and then a minus b over a cubed plus b cubed. Then we can combine the like terms here. We'll write this as a minus b squared times a plus b, all over a cubed plus b cubed. So that is our solution for this example. Notice we can't simplify any further, but that's our solution. So here's another example where we have a complex fraction, and we're going to take the top and the bottom, simplify them both on their own, and then we're going to get rid of this big fraction bar by flipping the bottom one and multiplying. But let's factor the top first and see if there's anything we can cancel. And what is this expression up here? That looks like a perfect square. So how do we factor a perfect square? Well, we have the square root of the first term and the square root of the third term, and then we have the sine of the second term, all that squared. So that's factored all over a minus b. Oh, look at that, and we can cancel. But let's do our bottom. Can't factor a cubed plus b cubed, a cubed plus b cubed. And then here we have a difference of squares, which we know how to factor. How do we factor a difference of squares? You do the first term, square root of the first term, minus the square root of the second term, plus, times the square root of the first term minus the square root of the second term, right? That's how you factor a difference of squares. Nothing cancels there, but we can cancel one of the a plus b's, right? So now we're just left with a plus b over 1 on the top. So now that we've simplified both the top and the bottom of the big fraction, we can get rid of this fraction bar by dividing the bottom part by the top part. So I'm going to skip the step where I write this as a division problem, and I'm just going to come up here and write our numerator here, the top of the big fraction, times the bottom fraction flipped, aka divided by the bottom fraction. So we have a plus b, a minus b over a cubed plus b cubed. So if we multiply this, we can combine the like terms here. We have a plus b times a minus b squared, right? All over a to the power of 3 plus b to the power of 3. And that is our solution for this example.
Hey guys, if this video has been helpful to you, click the link in the description to get access to the complete Easy STEM Algebra 1 system, which includes a textbook, homework, and all of the course videos in order.